Hi everyone, today I'm gonna talk about what I do as a MEP Revit / BIM Technician. Hope this is of interest to you. My main activity is 3D modeling of MEP services, but I also have to work on 2D schematics and layout, families creation and documentation, and I'd like to talk a little bit about everything. Let's start from 3D modeling. As soon as I get a new project and a short brief from a BIM manager, the first thing I do is go to Common Data Environment, or we can simply call it Digital Repository. Basically, they normally give me a link to, let's say, a viewpoint for projects, where I have an access to the latest drawings, technical submittals, schedules, and so on. Unfortunately, I cannot show you that due to the confidentiality. Let's say I've been told to work on level 3 and I need to model all the services in the corridors. Straight away I download the drawings the MEP designers prepared for level 3. Normally those are 2D drawings, but sometimes we also get 3D model, but there are thousands of clashes. Also, I download general arrangement plans, reflected ceiling plans, structural drawings, technical submittals, schedules. Design layouts from MEP designers look like this. Normally you get coordinated drawing with all the services on one sheet, and here I can see that I need to model the services such as domestic pipework, electrical containment, sprinkler, low temperature hot water, both flow and return. Then I get the drawings showing each individual service, one service per sheet, such as boosted cold water, LTHW both flow and return, sprinkler, and electrical containment. I'm gonna model it, and for the sake of this video I'm gonna model just a short bit and rely on design layouts only. I'm gonna ignore the schematics and the rest of the drawings, such as architectural and structural drawings. I'm gonna start from boosted cold water service, and I can see that I need to model 5 pipes. So I'm gonna choose boosted cold water service from the MEP fabrication parts browser in Revit. Diameter of the pipe is 22 mm and insulation is 40 mm thick. I need to place 5 pipes. I'm gonna keep 100 mm distance from the wall to the pipe's insulation, and I've also been told to keep 40 mm between the pipe's insulation. As well as that, I need to keep 50 mm between the underside of the slab and pipe's insulation. Again, it depends on the project, as some pipes may require certain fixings, such as LTHW may need expansion anchors, and you may need to keep 75 mm. It depends on the anchor's size, etc. But for the sake of this video, I'm gonna keep it simple. So let's start modeling. As I said, I'm gonna choose cold water, boosted cold water service from the MEP fabrication parts. Diameter of the pipe is 22 mm. I'm gonna place it. Make sure that the insulation is 40 mm thick. I'm gonna reduce the length. Make sure that it's 100 mm from the wall. I'm gonna copy it down. Make sure that the distance between insulation is 40 mm. And as I said, I need 5 pipes. So I can copy it down just like so. As well as that, I need to make sure that it's 50 millimeters. There is 50 millimeters distance between the underside of the slab and pipe's insulation, just like so. The next surface I'm gonna model is LTHW. The diameter of the pipe is 40 millimeters. Insulation thickness is 40 millimeters, and again I'm gonna keep 40 millimeters distance between pipes insulation. So let's model it. I'm gonna choose LTHW flow. As I said, diameter of the pipe is 40 millimeters. I'm gonna reduce the length of the pipe, place it, make sure that I've chosen the correct insulation, and double check that yes indeed it is 40 millimeters. As I said, I'm gonna keep 40 millimeters between pipes insulation. And the same I'm gonna do with the return surface. 40, return, choose correct insulation, place the pipe, reduce the length, and make sure that it is 40 millimeters away. And then I need to make sure that it is 50 mil from the underside of the slab. And I want to keep all the pipes at the same level. So I'm gonna move all these 5 pipes down to make sure that all the pipes are at the same level, just like so. Then I'm gonna model sprinkler. I was told that the diameter of the pipe is 40 millimeters. No need for insulation. I will keep 165 millimeters distance between the wall and sprinkler to allow some space for the LTHW IV valves. And I'm gonna keep it at 2555 millimeters height from FFL to keep it between the domestic and LTHW pipes and containment. So there are no ups and downs, so we don't need any air vents and drain cocks. It's time to model it. As I said, it's 40 millimeters. Height is 2555. I'm gonna reduce the length to 1 meter. Place the pipe. Make sure that it's 165 millimeters away from the wall. Just like so. Next, I'm gonna model containment. I'm gonna place DNO basket 210 by 59 millimeters size, and gonna keep it 250 millimeters away from the wall. And then LV basket 110 by 59 millimeters size, and keep it 50 millimeters away from the DNO basket. And then 50 by 50 fire alarm tray, and keep it 200 millimeters away from the LV basket to allow some space for lighting. And finally 310 by 59 millimeters ELV basket, and keep it 50 millimeters away from the fire alarm tray. I'm gonna position them at the height so there is 100 mil distance between the underside of the ceiling and the underside of the containment to allow some room for light. Let's model it, and the first thing I'm gonna do is hide the pipes. Next, I'm gonna place the DNO basket. 210 by 59 millimeters. I'm gonna keep it 200 millimeters away from the LV basket. And keep it 50 millimeters away from the fire alarm tray. And finally 310 by 59 millimeters ELV basket, and keep it 50 millimeters away from the fire alarm tray. I'm gonna position them at the height so there is 100 mil distance between the underside of the ceiling and the underside of the containment to allow some room for light. Let's model it, and the first thing I'm gonna do is hide the pipes. Next, I'm gonna place the and the size is going to be 210 by 59. I'm gonna keep it 250 mil away from the wall. Next I need to find LV basket. 110 by 59, correct. Place it. Make sure that it's 50 millimeters away from the DNO basket. Then I'm gonna place a fire alarm. This time it's gonna be tray. I need to find 50 by 50, but I can see I don't have 50 by 50 size, so I'm gonna choose this one is 75 by 25, so I'm gonna choose this one, so at least 75 by 50, so at least one dimension matches. Make sure that it's 200 mil away to allow some space for lighting. And finally I need to place ELV basket again, and the size is going to be 310 by 59, correct, and keep it 50 mil away from the fire alarm tray. I'm going to reduce the length to 1 meter. And as I said, I want to keep 100 mil distance between the underside of the ceiling and the underside of the containment, just like so. And all I've got left to do is model the branches that go into the apartment. So I'm going to switch to the 3D view. For now I'm going to switch off the rest of the models, such as architectural and structural. And I'm going to start from the boosted cold water. Show services. The diameter of the branch pipe is 22, so I need to find equality, which is this one. Direction is correct. Create similar. Reduce the length of the pipe to, let's say, 150 for now. Find 90-degree elbow. Make sure the direction is correct. Create similar. I'm gonna go to plan view, stretch the pipe, and make sure it's approximately 30 mil away from the doorpost. 30, correct. The next pipe is going to be a return pipe. I think it's this one. Yep, that's the one. I'm going to hide the containment. Show services and find reducing to, because the diameter of the branch pipe is 32. Change the size of the reducer to 4032, and then create similar. Change the length to, let's say, 150 for now. Find elbow, make sure the direction is correct. Create similar. And I can see that the insulation on the elbow and reducer is not the one I need, so I'm gonna change it to LTHW. Apply, and then stretch the pipe. Again, make sure that it's 40 mil away from the pipe insulation. The next one is going to be LTHW flow. Show services. Flow, correct. I need a reducing T. Change the size to 4032. Apply. Create similar. Yep. Change the length to 150. Find elbow. Create similar. Make sure that the insulation is correct one. LTHW. Again, stretch the pipe. Make sure that it's 40 mil away from the insulation. 40 mil between insulations. And finally, I need to model sprinkler. I know that the branch of the diameter of the branch pipe is 40 mil, so I need to find equal T, which is this one. Change the direction, create similar. Nope. Create similar. Yes. Reduce the length of the pipe to, let's say, 500. Yep. Make sure it's 40 mil away. And I can now change the height of these three pipes slightly higher so there is no clash. I'm gonna raise them slightly higher, just like so. Copy the height of this pipe and apply it to this one, so all the pipes are at the same level. So the pipes have been modeled, and all I need to do is model the containment branches. The only containment branches that need to go into apartment are DNO and ELV. So I'm going to go to the floor plan view, hide the pipes and unhide the containment. And I'm going to start from the DNO basket. Show service, find unequal T, create similar. Make sure that the size is correct, 110 by 59. Change the length to, let's say, 500. Move it slightly to the right hand side. I'm gonna go to the 3D view. Slightly stretch the section box. Make sure that there is 40 mil distance between the pipe and containment. Just like so. And let's say I want to lower a sprinkler. Let's say I want to make 50 mil between containment and sprinkler. As well as that, I want to slightly lower these three pipes, just like so. And now let's model ELV basket. I'm going to create similar. change the size to 110 to 59. Make sure that it's 50 mil away from the containment. 50, and make sure that there is approximately 30 mil distance between the doorpost and containment. Now I need to find show services. I need to find reducing T, unconnect it, disconnect it, align this branch with the reducing T. I need to raise this branch higher to make sure there is no clash. I'm gonna stretch sprinkler to make sure that the containment is not clashing with the sprinkler. And that's fine, I'm gonna delete it. Okay, I'm gonna make it 2600. I'm gonna copy this level and apply to this one. Connect it. And connect this one by using the root and fill command. Okay. Yep. I can see there are no clashes. And just to make sure that there is enough room, I'm going to stretch this and this. Yep, I'm happy with that. I'm gonna undo it. Once this bit has been modeled, then you stretch the services as per design and schematics, and wherever possible, you copy what you've done to speed up the process. Although this project is not too complicated and clashes can be spotted in Revit, I normally export it into Navisworks anyway to check for clashes. Again, you model a certain bit of the corridor, export it into Navisworks, check for clashes, then again model, export and check. I haven't done a clash detection test for this project as it's not too complicated. I just did a fly-through, which should be enough. In the next part, I'm gonna talk about what we normally do in Navisworks, and I'm gonna talk about the rest of the activities. Thanks for watching.